Hi guys, good afternoon. So in the last session, we started with the EIGRP, right? And I gave you some questions. First question. What was the first question? Hmm? So question number one was, what packets in EIGRP are unicast or multicast? No, same thing, unicast, multicast, broadcast, anything. Then hello packets. Okay. First one is hello packet, which is multicast. Then update packet, both multicast and unicast. Then query. Okay. Both multicast and unicast. Then reply is unicast and acknowledgement. So overall, that means not all the packets are multicast only. Not all the packets are multicast only. Some of the packets are multicast, some of the packets are unicast. So this thing we will discuss when we are talking about the EIGRP packet types. This is clear? Okay, question number 2. Router ID of a router by default. Okay. That is the router ID election criteria. Hmm? The IP that we assign, okay. I'm saying that I have only given the, I think first question was this thing, router EIGRP and ASM. This was the question. This was the first question, I guess. That what happens when you execute this command? Initialize the EIGRP, okay. Will be created, okay. That's it. This is all the things. Yes. Thank you and congratulations. That's all the basics. Thanks for guys, congratulate him. He just got placed in Barracuda. Because of time, if you have any interview done, implementation class, be good for you. Because of implementation, I joined Barracuda. Thank you. Thank you so much. Thank you, and once again, congratulations. Anybody wants to have it? Have it. You have a cavity. Okay. So question was, what happens when you give this command in a? So when you give this command, let's say router EIGRP and ASM. First of all, routing protocol will be enabled. First of all, what will happen? The routing protocol will be enabled. Then what else will happen? right? For a given ASN, your EIGRP domain will be created or the EIGRP process is going to start. Then
wait for network advertisement for the start.
that means until or unless you give a network. See here. Hmm?
And of router ID.
Hmm.
Sir, router advertising network ID of the path router ID हो जाएगी.
Hmm. Okay, you can manually assign router ID, not a problem. Now see here. Okay, what was the next question other than that? Hmm? Total types of metric or how many matrices are there? So how many? 7. What are those? 6 only. AD. Administrative distance is a metric. Hmm. Missing something important. Missing something very important. Cost. OSPF, right? Uses cost. Okay. So total matrices are bandwidth, load, delay, reliability, MTU. So this is used by with remaining all EIGRP. These are all used by EIGRP. Okay. This is clear. Okay. Now coming to the next thing. That what happens when you give the statement router EIGRP? Yes, sir. So this is a lot, but as of now, I'll just use only one separate router. Now let me create a new lab itself. You guys also prepare well, and you'll also bring sweets, right? Very soon. Barracuda and a good package. Not to disclose. Confidential. Yeah, CCI security. Start all the notes. One more student got placed in Barracuda recently. Nothing. So this side, let's say we'll use 192.168.12.1. Hurry. Got this. Hmm? Pradeep got placed here. Pradeep, Suhas, Parveen. Okay. Let's take an access. This is R1. Once you complete routing switching, start attending the interview prep and start attending mock interviews. And don't skip the communication process. Okay. Let's say this router. So when I asked you what will be the router ID, what did you tell me? The IP address. Hmm? See, if I say debug IP routing, Okay. Now see, if I say router EIGRP 100. Let's see what happens. Did anything happen? Okay. Now if I check do show IP protocol, you can see EIGRP 100 is running. EIGRP 100 is running. But do I have any networks right now? No. Okay. Do show IP EIGRP. How do I check router ID in the EIGRP?
So I think so.
Hmm?
So I think they are not the router idea. No, it is the router idea.
Yeah. Yeah.
Yeah, not the same.
Mm-hmm. Yeah. So it said no usable router ID found. So that means what is my router ID? Not assigned.
Yeah, so I think it's get that.
Not down. If EIGRP is not able to assign a router ID, if EIGRP is not able to assign a router ID, it will use 0.0.0.0 as router ID. If EIGRP is not able to assign a router ID, it will use 0.0.0.0 as router ID. This is clear. Okay. So can I configure 0.0.0.0 manually as a router ID? Yes or no? No. You can see here. Mhm. So can I configure it or not? No. Yes. No. Yes or no? No. So see here. If I try, how do you configure router ID? Router ID. If I try 0.0.0.0, what it says? Okay, tell me, can I send this? Yes or no? Yes or no?
Yes, sir.
Online people, yes or no?
Yes, sir.
Hmm?
Yes.
Yes. Yes. Here that logic will not work. That zero network you don't use anywhere. You can assign 0.0.0.1. Okay, what if I try something like this? Can I assign? Yes? No? Hmm? No idea. You cannot assign because router ID is a 32-bit number that is in the IPv4 format. See here. Router IDs says why unrecognized command. The command is EIGRP router ID. Now see here. What is the router ID? 0.0.0.1 now, right? Check. Do show IP EIGRP topology. Right? You see here, I use the command to assign, right? This is the command I used to assign. But also you can assign it using this command, EIGRP router ID. Same. Clear? No. So about router ID, what you need to mention that EIGRP router ID is a 32-bit number, or even OSPF also same. That router ID is a 32-bit number that is used to identify a router. Okay, and it is in the IPv4 format or IP address format. This is clear? Okay. So you can say
Sir,
yes.
can we assign router ID on global exec mode?
Sorry.
Can we assign router ID on global exec mode?
No.
When?
You have to be there under EIGRP configuration. From global configuration mode, you cannot assign the router ID.
Okay. Thank you.
So router ID. Router ID is a 32-bit number that is represented in IP address format and used to identify a router in an ES. In an autonomous system, it is used to identify a router. This is clear. Now, if we talk about router ID election criteria, so first preference is given to manual configuration. Number two, if not manually configured, highest IP on any loopback interface will be the router ID. Okay. If no loopback is present, highest IP on any physical interface is elected as router. This is clear. Okay. Next thing, wait for it. Action criteria, then that note that if a router configured with the EIGRP is not able to assign a router ID, it will use 0.0.0.0 as the router ID. Okay. This is what it is going to use. Now, another thing about router ID is what? That let's say, for example, I have a loopback interface. I have a loopback interface. So let's say interface loopback 1 IP address. And let's say, for example, this is R1. So 1.1.1.1, 255.255.255. Done. So this has been added to my routing table. And if I say no router EIGRP 100, now I'll say what? Router EIGRP, and let's say 1. Done. Now this is going to have some router ID. What will be the router ID? Low back, correct? Okay. So let's check do show IP EIGRP topology. You can see for AS number 1, what is the router ID? 1.1.1.1. Okay. Now if I say router EIGRP 2, what will be the router ID? Why? Okay, got it. So you mean to say that EIGRP can have duplicate router IDs? Hmm? You mean to say that EIGRP can have duplicate router IDs? Correct? Agree? What will be the router ID? Hmm? Because 1.1.1.1 is already used as a router ID for ASN1. 0. Why? No IP given. Okay, so okay, what I'll do is no router EIGRP2. Then I'll say interface gig 0/0 IP address 192.168.12.1 255.255.255.0. No checkbox. Okay. Host name R1. Add it. Now I check here, do show IP EIGRP topology. Again, AS number 1 is having the router ID. This. Now if I say router EIGRP2, now what will be my router ID? One dot one or 192.168 or 0? 1.1. Everybody agrees? Let's check. Correct? Okay. Then if I say router EIGRP3, what will be the router ID? Same. Correct? Okay. Now, if I say here same thing, router OSPF1, what will be the router ID? Hmm? What will be the router ID? Think about it. What will be the router ID? Same. Okay. Do show IP OSPF database. So we can see router IDs. Okay. If I say router OSPF2, what will be the router ID? Hmm? Same.
Yes.
Yes. What happened? Okay. If I say router OSPF3, what will be the router ID?
0.
0 wala. 0.0. No idea.
0.0.0.
Sure.
I think.
I think. I also think. Sometimes. See? See what happens in OSPF. What OSPF is telling? What? It's not even starting the OSPF process. Doesn't it's saying what? OSPF process 3 failed to allocate unique router ID and cannot start. The process itself will not start. The process itself will not start. This is clear. So if you check right now, we have only 2 processes. See here about process 3. If you want to run the process 3, you have to configure a router ID. It's not like EIGRP that okay, we can use the same over and over again. Right? This is clear. Okay. So what did you understand from here? What did you understand from here? OSPF for OSPF requires a unique router ID. But what about EIGRP? On a EIGRP router, you can have multiple processes, and multiple processes can have same router ID. Okay, note it down.
Sorry. Hello.
Yes.
It's like different protocols communicate using by router ID. Is it like that, right?
Like what? Come again?
It's like different protocols like OSPF, EIGRP, and all.
Mhm.
Same router ID to communicate with each other.
No, they don't communicate with each other. Okay, different protocols don't communicate with each other until or unless you configure redistribution. After redistribution, they can exchange routes. No conflict. Now see here that a router can have multiple EIGRP processes running and multiple EIGRP processes on a router can have same router ID. Why? Because EIGRP does not check for router ID duplication. Clear? EIGRP does not check for router ID duplication. Got it? Okay. When you'll come back in mock interviews, same depth I'll ask. So be prepared. Okay. Okay. Now see here. On R1, if I check to EIGRP topology, so Okay, only one process is running, that is 1.1.1.1. Okay, AS1 with 1.1.1.1. So let's say if I check to show IP interface brief, you can see I have one IPS 1.1 and another IPS 192.168.12.1. So tell me one thing, if I go router EIGRP1, okay, and if I say EIGRP router ID, can I configure it something like, let's say if I want to configure loud. Yes or no? I can configure. That means whatever the router ID you configure on a router doesn't have to be present on any interface. It doesn't have to be an IP address that is present on any interface. Clear? Simply how you can mention it, router ID does not need to be configured on an interface as an IP address. It doesn't have to be an IP address on a physical or loopback interface. Anything manual you can configure. Okay. So you can say here that router ID does not have to be present on an interface, or you can say present as an IP address on a physical or virtual interface. Sorry, loopback interface. It doesn't have to be like this. Clear? Okay. So router ID doesn't have to be present as an IP address on a physical or loopback interface. You can configure anything manually. Understood? Now, so on R1, I have configured the router ID as loud. And we know that router ID is used to do what? It is used to identify a router in IAS, right? So if I go on R2, let's say no. And here I'll also configure network, but I'll come to that. First, let's discuss this part. So tell me one thing, can I configure the same router ID on R2 also? In a AS, again, I'm telling, okay, listen to this carefully. In a AS, can two routers have the same router ID? Yes or no? In an autonomous system, can two routers have the same router ID? Yes or no? How many of you say no?
No, sir.
Everybody says no. How many of you say yes? None of the above. Yes or no? Yes. The only one person is right. Only one person is right. So in IAS, because again, like I said, EIGRP does not check for the duplication of router ID. So in IAS, more than one router can have the same router. So what is the reason behind this? First, note it down. In an AS, more than one network, sorry, one router can have the same router ID. Why? No, that is not the reason. That was the reason when we were checking the processes on the same route. Here, what is the reason? Because in EIGRP, router ID is local to the router only. EIGRP does not share the router ID information in the hello packet. Like I have set, right? If you see here, I have configured EIGRP here. So if I will give a network statement, I should start seeing the things, right? I should start seeing the hello messages on this interface. So let's go and configure it. Okay. On R1, I'll give the network statement. Let's say one network 192.168.12.0. Done. Now we will see some EIGRP packets here. The EIGRP hello packets. This is the hello message. In this EIGRP message, you will never see anything related to router ID. It says virtual router ID is 0, but other things not there. Only hold time information K1, K2, K3, K4, K5. Do you see any information related to 11.11.11.11? No, because EIGRP does not include the router ID information inside the hello message. So if nobody is sharing their router IDs, how the ASN people will come to know that we are having the same router ID or different router ID? They will never come to know about the router ID. And that's why in case of EIGRP, you never study about router ID. In your CCNA, you were not taught about router ID in the EIGRP. You were taught in the OSPR. But it is also present in the EIGRP. Is it clear? Okay. So note it down. EIGRP does not include the router ID information in the hello packets. Okay. Does not include router ID in the hello packets. Now, one of the question was how many EIGRP instances you can have on a router. How many? How many EIGRP instances you can run on a router? That means how many EIGRP you can configure, like 1, 2, EIGRP router EIGRP 1, 2, 3. How many you can configure?
Multiple.
Okay, how many? 65,000. I'm not talking about AS. That what is the range of the AS? That is 65,000. So how do you check? This was very simple answer. You could go here. You would say router EIGRP 2, 3, 4, 5. Okay. Time control 0. Login synchronous. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 27, 28. Oh, that is 29, sorry. You see, process number 30. What it says, too many IP routing processes could not create router process. So maximum up to 30 you can create. Sometimes even the 30th process you cannot create. Like we can see here, right? 28, this was 29. I tried to create the process number 30. What did I get? Too many IP routing processes could not create the router process. Understood?
Sir, then what is this range?
Which
1
range?
to 65,000
That
something.
means in here, whatever you are typing, anything you can type between 1 to 65,000.
Okay.
Okay, that doesn't mean you can create that many.
Okay, sir. Thank you.
Okay. Clear? Now, instead of saying no, I'll just reload the router. So note down that on a EIGRP router, we can create up to 30 EIGRP processes. On a Cisco router, sorry, not that EIGRP router. You can say on a Cisco router, we can create up to 30 EIGRP processes. That means these many processes can run simultaneously. This is clear. Now, next question. Okay. Next question is, let's say you configure EIGRP. You give this network statement. What happens when you give this network statement? Whatever the command you execute, you should know what does it mean. This one. Network ID or any command. What happens when you execute this command? Okay. Hmm. But what will happen? It will start sending hello packets. One. What else? Just now I showed you this thing as a practical. That once I gave the network statement, it started sending hello packets. What else? Hmm. What else? No idea. Anyone online people?
That network became a part of an autonomous system.
Hmm?
That network
Mm-hmm.
became a part of an autonomous system.
That network became a part of autonomous system. How? Once you give network statement and it will become network. For that, there has to be somebody on the second side also. What if somebody is not available? I'm asking what happens on a router. Locally on a router, what happens? When you give the network statement. Everybody knows that, okay, if two routers are there, you configure the network, configure EIGRP, they'll become neighbors. That is common. I'm asking you something that is not common. If you feel like depth is too much, you can tell me, we can just reduce it. No? Otherwise, I'll keep on asking questions. Online people, it's fine, right?
Yes,
Sir,
sir.
question come again.
The depth of the training, me asking a lot of questions, is that okay with you guys? Right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So then keep on answering me. So tell me, what happens when you give a network statement? When we give the router EIGRP statement, we came to know that, okay, one thing, EIGRP is enabled, EIGRP process will start. Second thing, we came to know that, okay, if a router ID is not available, in that case, it will select 0.0.0.0 as a router ID. That command is done. Now, what happens when you give the network command? Where? Without having neighbor, how it will advertise? Without having a neighbor, how is it going to advertise? Hmm? Okay, let me explain. So now let's talk about EIGRP network statement. How do you give a network statement in EIGRP? You say router EIGRP ASN, then you will say network ID, and you'll give a wildcard, right? These are the things. Now, what happens when you give this network statement? The first thing that happens is on that interface, whatever the interface this network is available, on that interface, EIGRP is enabled. On that interface, EIGRP will be enabled. Second thing, that interface will become member of the multicast group 2240010. Before that, the interface is not a member. As soon as you give the network statement, the interface will become a member of the multicast address or the multicast group 2240010. Okay. Number 3, it will start sending hello messages through that interface. It will start sending hello messages through the interface. Number 4, it will add that network or the route in the topology table. These are the 4 things that is going to happen. Clear? So note down. Once a network statement has been given, what will happen? Number 1, EIGRP will be enabled on that interface. Okay. Interface where the network is configured, right? Number 2, the interface will become a member of the multicast group. Okay. 224.0.0. Number 3, EIGRP will start sending hello messages to the interface where the network is configured. Clear? Number 4, EIGRP will add that route in the topology. Clear? This is our second week or third week? Third week. Okay. We'll complete in this week only EIGRP. So 2 weeks only static is studied. All was static only, right? Still 2 weeks, too much. In CCN, you completed in like 1 hour only. Not it? So if I say no here, see right now if I check to show interface Z0 by 0, anything related to multicast address here? If you can see. Okay, let me do one thing. Okay. So anything related to the multicast address here? Hmm? 0? Nothing, right? Okay. So we don't have anything. Okay. This is one. Second thing, do show IP interface Z0 by 0. Detail. Detail keyword is not there. Okay. The interface is administrative down right now. Fine. So if I go to interface gig 0/0, IP address 192.168.12.1, 255.255.255.0. Okay. Now let's check. To show IP interface gig 0/0. So do you see anything related to multicast here? Only we have the IP address and the broadcast address. Correct? Rest of anywhere we don't have any detail related to multicast. Correct? Okay. And also let me show you that command. Do show interface gig 0/0. Here also. Do you see any multicast? Yes or no? No. Okay. Router EIGRP 1. Okay. So right now, if I check, do show IP EIGRP topology. Do you see any route in the topology table? No. Okay. Then let me start capturing the packet also. So you can see hello messages are also not being sent through this interface. There is no hello message, right? Only some other messages are there, but EIGRP message is not there. Okay. So now what I'll do, I'll give the network statement. Network 192.168.12.0. Done. Now check here. EIGRP started sending hello messages. Okay. What about the topology table? If you check the topology table, route has been added to the topology table. 2 points verified. Okay. Do show IP protocol. Okay. So you can see it is routing what networks? 12.0 networks. Okay. So if I check the interface now, do show IP interface 0/0. See here. Has joined the multicast group 22400. Earlier, this was not there. Understood? Verified? Okay. Now, let's say if I give network and 192.168.23.0, what will happen? Will the EIGRP accept it? Yes or no?
Yes.
EIGRP will accept it. So that means the same process will happen here also. Yes or no?
Yes.
Yes. Let's check the topology table. What happened? Hmm? Mhm. Tell me the reason why it is not added to the topology table.
Because it is not added to any interface.
Sorry,
I mean, the IP address is not added to any interface.
what is topology table in EIGRP? What is topology table?
But it shows the IP addresses configured. I mean, with the EIGRP,
So
the
that,
networks which you have configured with the EIGRP.
okay, the networks that I have configured with EIGRP. That means if my neighbor will share me some routes, then that information will not be there. Will be there, right? That is also not configured on my router, but still be present in the topology table. Then what is the problem? The problem is reachability. The problem is reachability. Before adding these routes to the topology table or enabling EIGRP, it will check the reachability. Even static routes are not added without reachability. How come dynamic routing protocols will add it? Think about it. If reachability is not there, static routes are not added in the routing table. How come dynamic routing protocols will add them? Right? So you can say one simple statement. For all above processes to happen, there must be a route for the network in the routing table. Simple. There must be a route in the routing table. And if there is a route in the routing table, that means it is reachable. It is reachable. See, we can try that. If I say IP route 192.168.23.0, 255.255.255, and let's say I'll give it 0.0. Without configuration, we have it. Why? Because in my routing table, I have a route to reach that network. Understood? Black magic. Yeah, you see this. This network does not exist, but still somehow I brought up this route in the routing in my right in my topology table. Why? Because of this route. There. Hmm? Communication will not be there. Communication. This is a static route only. Because of this route static. Because of the static route, it has been added here. Clear? And if I will say no to this one, again it will be removed from my topology table.
Sir, what it means R static. Route static, right?
This is a connected route. This is a static route configure. So R static is nothing but the static route configure. Clear?
Okay.
Now, this is clear. Okay. So you can see that for all these above processes to happen, there must be a route for the network in the routing tree. So if there is no route, nothing will happen. If there is a route, everything will happen. Clear? Okay. Now I gave you a task to go with these things. That what is the difference in these two? Between the network statement and network with the wildcard. What is the difference? Okay. And hmm? Okay. Is it true? Hmm? So when you use wildcard mask, it is classless, and when you don't use wildcard mask, it is classful. This is what you're trying to say. Okay, let's see. So did you think I'll give you a very simple task? Hmm? Something regarding subnet. What kind of thing? Is it? 10.110/24, 20.110/24. I think. How many networks I gave? 2 or 3? 3. 30.110/24. So first, I'll configure everything without or with wildcard. How should I configure it? Tell me. Without. Okay. So this is host name R1. Already we can see it will show run 5 section EIGRP. We don't want any conflict. So R1 side configuration, I'll remove this 23 network. Okay. So now you can see on R1, my EIGRP configuration is only this much. Yeah. Oh. Now here, host name R2, line console 0, logging synchronous, and interface gig 0/0, IP address 192.168.12.2. No shutdown. Interface loopback 1, IP address 10.112.255.255.255.0. Loopback 2, 20. Loopback 3. So done. You can check. All okay. Router EIGRP1, network 192.168.12.0. Done. This is classful. Network 10.110. This is classful. 20. Classful. 30. This time let me say 00025. Okay, now tell me on R1, how should I see the routes? What will be the CIDR for 10, 20, and 30?
Running config.
For 10, what will be the CIDR in my R1 routing table? 8 or 24? /8. Everybody agrees? Hmm? 10 network. For 10 network on R1 routing table for 10 network, what will be my CIDR? 8. 8.
Yes.
8. Same. 8. 8. 8. No. No CIDR. 10, 16, 24, 32. No idea. Online people, 8 or 24?
8.
8. 8.
8.
What happened? Which website you refer? Or ChatGPT? No? Oh, you did practical. Where did you do the practical? EVNG or packet tracer? EVNG only. See. So why then I am seeing here 24? Hmm? Auto summary. Okay. So what about auto summary here? So I didn't give no auto summary command, right?
Yes.
By default. By default what? If it is taking auto summary, that means it should summarize to the classical boundaries. Who disables? Sorry? Where? Exactly. The iOS version difference. The iOS version difference. Until the version 12.0, auto summarization was enabled by default. But after the version 12.0, auto summarization is disabled by default. Only 1% check the right reason. Okay. So note it down. Even though EIGRP is a classless protocol, until the Cisco iOS version 12.0, and to be specific, the revision number 4. Okay. The networks are by default classical. The network statement were by default classical. That means kind of you can say auto summary was enabled. Okay. In Cisco iOS version 12.0 revision number 4, and later versions. Okay. The wildcard bits are also attached. And before this version, you were not able to use wildcard. Okay. Attached in the network statement. So you can say in the older Cisco iOS version, auto summary was enabled by default. But in newer versions of Cisco iOS, auto summary, I think auto summary was disabled from 15 version. And whatever you tried, so maybe you tried in the older iOS version. Clear? .6. See, that depends on the image you're using. There are multiple images available for UNG also. Okay. Note it. Okay. Now, how many tables EIGRP forms? 3. What are those? So you can say EIGRP forms how many tables? 3 tables. Number 1, the first table is the neighbor table. Number 2 is the topology table. Number 3 is the routing table. These are the 3 tables your EIGRP is going to form. Okay. First one, neighbor table. What is the neighbor table? Hmm? Neighbor address. So simply I'll say here this contains list of neighboring routers. Okay. What about the topology table? What does it contain? Possible routes. Or I can say list of all routes. Okay. So this list of all routes. Majority of the routes, backup routes, they will be available in the topology table. What about the routing table? So this contains list of bus routes on. Okay. So this contains list of bus routes. Contains a list of bus routes. Clear? Okay, so Okay, what other questions I give? Yes, difference between neighborship and adjacency. What is the difference? Difference. Hmm? Routing table. That is fine. I understood adjacency is formed after neighborship. Difference I'm asking. And adjacencies are in the universal network. Huh? Different network. Hmm? Sorry. Adjacency. Somewhat okay. Hmm? Actively exchanging routing information. So neighbors are not exchanging. Adjacent, first of all, neighborship. Neighborship is the initial state where only your hello packets are exchanged. Though they will become adjacent when they have fully synchronized their databases, where they have fully synchronized their topology information. That time they will be known as adjacent. So that's why once all your different packet types, 5 packet types, they are exchanged, databases are fully synchronized, topology tables are fully synchronized. That time you will get a log that, okay, adjacency is up. Before that, you will not get it. That means at that time already the topology information is already synchronized. Is that clear? So how you will mention it? Not like this. So you see here, this is the neighbor, and now we have a new adjacent. So how we will note it down? We'll say about EIGRP neighbors. EIGRP form neighbor relationship with other routers in the same AS by exchanging hello packets on the multicast address 24.0.0.10. Okay. So you will say neighborship is the initial state that is formed when two routers in an AS have exchanged hello messages. So when they have exchanged the hello messages, that time they are neighbors. Adjacency is the deeper state. Okay, which indicates the information on the neighboring routers is fully synchronized. This is clear. Got it? Okay. Now, before we move further, note down task. Show IP EIGRP neighbors. This is first task. Contents of neighbor table. Task number 1. Okay. Yes. Contents of neighbor table. That okay, what are all these things in the neighbor table? What do you see in the neighbor table? Okay. Number 2. How many IP addresses we can configure? This thing we have already discussed, right? Multiple. We can have one primary address and multiple secondary address. So task number 2 is, can we form EIGRP neighborship on secondary subnet or a secondary IP address? Can we form EIGRP neighborship or adjacency on secondary subnet? These are the 2 tasks for you. Check, your neighborship will be completed. Then tomorrow we'll discuss about packet types. If you want, you can check about it. Okay. How many packets are there in EIGRP? Right? How many packets are there in EIGRP? 7. There are 2 reliable packets also, SIA query and SIA reply. So if you want, you can check about them. Tomorrow we'll discuss. Online people, any doubts so far?
No,
Sir, second task.
Second task is this is the second task. Take a screenshot, drop it in the group. Okay, guys, then this is it for the day. Let's see you tomorrow. Have a good day.